Okay, today we're going to be talking about and working with relations. And functions. Relations and functions. And we're going to say that a relation is a set of pairs of input and output values. A relation is a set of input and output values. Expressed by the following. What you know them as is X's and Y's, all right? A relation can be expressed as an ordered pair. All right, your X and Y values. You know, 2, 3, -5, -6. All right. Any set of input and output values can be called a relation. A mapping diagram. All right, a mapping diagram where we got an input and an output. For this same relation over here, if we input an X, we get a Y. If we input a 2, we get a 3. Input a -5, output -6. All right, so you've got this relation that can be expressed as an ordered pair. It can be expressed in a mapping diagram. It can be expressed as a table of values. Relation can be expressed as a table of values where you've got your X and your Y's and your input and your output. All right, so when you 2 and a 3, there's your table of values. Sometimes you see it, it looks like this. All right, you input a -5, you get a -6 as an output. So those are 3 of the ways that you can express a relation. All right, and then the 4th way is by a graph. On the coordinate plane, where you have your x-axis and your y-axis. Your x-axis is also your input axis. The y-axis also your output. So a way to express this relation would be on a graph. So if you had the point 2, 3 right here on the graph, if you had the point -5, -6, all right, those are the 4 different ways you can express a relation. All right, inputs and outputs. Everybody okay with that? Yes? Up a little bit? And if you want to go back here now, and this would probably make more sense, I should have done it the first time through. See where all these X's are, where you got the X, and then you got a 2, and then you got a -5? Just domain. All of your input values, all of your X values in a relation are also referred to the domain. If it's in the mapping diagram, your input is the domain. In a table of values, your X's, your inputs, those are your domain. X is always the domain, correct. The X's are always the domain. On a graph, the values along your X-axis, that's the domain. Which means the Y values or your outputs are always called the range. In a mapping diagram, you have an input and an output, and you have a domain and a range. And in a table of values, you have an input and a domain, and you have an output that is also the range. It's the range of the relation. This y-axis on the graph is your output. It's also the range of the relation. So if you're asked to list the range, list the domain, you're finding the X's. Right, so in this example, our domain is the X, right? It's the input. It's 2 and it's -5. Those are all of your domains. Your range for this relation, that's your Y. That's your output. In this case, it was a 3. And what else? The -6. All right, so a relation is just sets of numbers, inputs and outputs, domains and ranges, X's and Y's. Everybody okay with that? This data, a relation is a set of input and output values, okay? Now we're going to learn, or now you're going to be asked to determine if the relation is a function, okay? So you've got relations that are functions, and then you have relations that are not functions. Think about it this way. You have relationships, right? You have some relationships that are functional. They work. You have other relationships that are not functional. They don't work, right? We all know about that. So you can have relationships that are functions, and you can have relations or relationships that are not functioning. But you can have all kinds of relationships. So now we're going to learn how to determine if this relationship is functioning, functionable. All right. Now, another definition. A function is a relation in which each domain has exactly one range. A function is a relation in which each domain has exactly one range. So let's say that here's our domain. Here's our range. And we got a domain of -3, 0, and 4. And this -3 corresponds to a -2. And the 0 corresponds to a 7. And the 4 corresponds to a 1. And you're going to be asked something like, is the following relation a function? All right. Do you see how when the input is -3, the output's -2? And when an input is 0 and output is 7? And when an input is 4, its output is 1? So doesn't each of these domains have exactly one range? This is a function. As long as they're pointing to one value. Where each domain has exactly one range. Each domain has exactly one range. Each x has exactly one y. Here's the way that I can remember whether a relation is a function or not. I treat it like it's a machine. And if you put one thing into the machine, you should get the same thing out each time. Okay? So this is an example of a function. Here's what would make this not a function. Watch. If you take this arrow on the -3 and you put it here as well. You see now how this one input has two different outputs? That doesn't function, does it? That doesn't work. It's like you put gas in your car and it goes, and then you put gas in your car and it doesn't go. Well, that car ain't functioning correctly, is it? All right. But if you put gas in it and it goes, then it functions. So when I add this red arrow here, when I add a second range to this one domain, that is not a function. Okay. When one input has two different outputs, that's not a function. Everybody all right with that? That's one way to test your data. Here's another way. Let's say you get a function listed as an order, as sets of ordered pairs. You get 4, -1. And then you get 8, 8, 6. And 1, -1. And 6, 6. And 4, 1. And you're asked if it's a function or if it's not a function. Well, look what happened right here. You put in a 4, right? And what came out? A -1 came out. Input, output. And then you put the 4 in again. And what came out? A +1. Does that work? No, that's not a function. You put the same thing in twice. You got two different outputs. That doesn't work. Okay? That's non-functioning. There's another way that you can test a graph to see if it's a function. It's called the vertical line test. If a vertical line intersects a graph in more than one place, then the relation is not a function. Vertical line test. If a vertical line intersects a graph in more than one place, then the relation is not a function. So here's an example. If this is your graph, it might be easier to just watch right now instead of, once you have written down this vertical line test, once you've got that written down, you're better off watching right now than trying to copy this. Look, does a vertical line intersect this in more than one place? Here's a vertical line. See where it hits the graph once, twice? Not a function. Okay? This data, this input and output would not be a function. All right? They used to call it the pencil test. If you held your pencil vertically and you slid it from left to right across the graph, if your pencil ever intersects the graph in more than one place, it's not a function. All right, so that's what the red line represents. Look at this. If this was your graph, all right, function or not a function? Function, because if I took a pencil and I started over here on the left, there, it hits the graph in one place, doesn't it? And if I kept sliding this to the right, it's only going to touch the graph in one place each time, isn't it? So that's a function. That's how the vertical line test works. If you can touch the graph twice with a vertical line, it's not a function. If you can't, then it is a function. Everybody good with that? Okay. All right, and the next thing we need to talk about today is function notation. Function notation. A function can be written as the old y equals 3x plus 7. That's function notation. The x's are your inputs, they're your domains, the y's are your outputs, and your ranges. You've seen a lot of that. What you haven't seen a lot of is this function notation, where you read this f of x, which is short for the function of x, is equal to 3x plus 7. You read that as the function of x equals 3x plus 7, or f of x equals 3x plus 7. Here's how function notation works. Let's see how they word it in your practice. Evaluate each function for the given x. and write as an ordered pair. So let's say that you're given the function of x is equal to 10x plus 3. And you're asked to evaluate it for x equals 4. This is how function notation works. And people, I'm not going to say anything else. This is how function notation works. When you're going to evaluate this function for x equals 4, you write it this way. You write the function of 4 is equal to 10 times 4 plus 3. So your function of 4 is equal to, what's 10 times 4? Plus 3, 43. Now you've got to write it as an ordered pair. So look, what was our x value in this? It was 4. What was our output? What was our range? When we put a 4 in, what came out? 43. This is it in function notation. This is it as an ordered pair. What this means over here, what this means is when I put in a 4, I got a 43. That's how function notation works. It allows you to always determine what your input was for a given output value. If you have to evaluate the function of x for 2x minus 12 when x is equal to 3, it's the same process. We write the function of 3 is equal to 2 times 3 minus 12. So our function of 3 is equal to 6 minus 12, and that would be negative 6. And then if we write it as an ordered pair, our input, or our x, was 3. And our output, or our y, or our range, is negative 6. Got it? All right. So here's some practice for you today. Going to be on page 65. Going to do problems 10 through 24. Page 65, problems 10 through 24. And let me find that for you.